There it is. Hello, welcome to Washington State College Statistics 2110. This is the last section of Chapter 2. We'll talk today about analyzing graphs, and we want to spend a little bit of time especially on how identifying misleading characteristics of a graph. So let's talk first off about how to properly label a graph. Should have a title, something meaningful and understandable that tells you what the graph is about. Sometimes there's a bit of a sometimes there is a subtitle that adds a little bit more, a little bit more detail to help you interpret it. If it's inside an article, if it is within an article, usually the title will be gone and there will be a caption containing that information instead. Usually it's a little bit more in depth. Um, the You'll have a title each. Either you'll have titles for the bars or you will have titles for each axis that explains what you're seeing. So you've got, in this case, you've got bar titles. These are the names of the different generations. And instead of having an x-axis, you've got the frequency numbers written at the end of the bars themselves, it's giving the same information. So you've either got the axis with appropriate title and unit information, or you've got the data points listed on the graph. Then it's important that you've got the source, or generally important that you've got the source where the information came from. If it's your own information that you're reporting, then that you wouldn't need that. But if you're reporting someone else's information, you would expect to see that. Time series graph is a line graph that is used to display a variable whose value changes over time. The other option is cross-sectional graph, which displays information collected only at one point in time. They're treated slightly differently. We've also got pictographs, which is a bar graph that uses pictures of objects instead of bars. In the textbook at the beginning of Chapter 2, they have let me see if I can hold it up to the camera visibly. They have a pictograph there with there we go, calling rates using coins instead of bars. You need to be a little bit careful about that because in that one they've got the value of the coin is what tells you the size of the bar, but your 2 cent call to India and the 2 nickel call to France look the same size because you know they're visibly the similar sizes. So pictographs can be deceiving for reasons like that. Either you've picked something kind of tricky so the bars look the same size but show different values, or as in this example, um, they here in the one where that's incorrect, they've scaled the entire house instead of just adjusting the height. If you were to think of this as a bar, um, you've got bars the same width at different heights here. Here the bar has gotten wider as it's gotten bigger, so they've scaled this way. So this looks a lot worse than this. So looking at this, you're like, oh wow, this is a big problem with housing prices. And this one, it's okay. You can kind of see a consistent, smooth trend. I mean, it's maybe still a problem. I'd have to adjust for inflation to know, but you can see how they've chosen to size the pictograph has made the graph somewhat deceiving. Another thing you need to look at is that the graph is scaled properly. So if you stretch or shrink the scale of the y-axis, the shape of the graph could change dramatically. So if we look back at this one, if we made this go out to $1,500 for some reason, then this wouldn't be that big an increase, right? If we stopped at 900, and maybe started at 300 instead of 0. Actually, that looks like it starts at probably 100 or maybe 150 instead of 0. So it's already got some scaling issues there probably. So if we started somewhere different, we can make it look a little bit worse or a little bit better depending on how we scaled that axis. So if it's gentle on one scale, it could look very steep on a different scale or look positively flat. So you have to double check that the scale represents the data well. So their example here that they show is it's not in this case it's not the y-axis that's messed up. So take a minute, look at this, and take a look at the x-axis and think about what is wrong with this and how it might be skewing things. And unpause when you're ready to proceed. Okay, so the first thing you need to note is that the x-axis doesn't have a consistent scale. Some of these are just 1 year apart, so October to October 1938. Suddenly we're jumping 6 years here, still in October. Suddenly we're changing seasons and jumping 5 years. The jump can get up to 9 years apart in places on that graph, so that the whole shape is distorted. They've included the corrected graph in problem 210 in the book, so hopefully you can see this in the small window for those of you who don't have the textbook yet. That's what it should look like corrected if you adjusted the x-axis to be a nice consistent scale. You can see there's some spots, some of these spots get stretched out nicely right in here, 81 to 99 or 90. It changes the look of the graph quite a bit. Okay, I'm going to talk a little bit about shapes of graphs. These tend more to be shapes of distributions than some of the other types of graphs. You can have a graph that's uniform, symmetric, skewed to the right, skewed to the left. You can also have outliers, which is the data that falls way out of line with everything else on the graph. So here's a nice example of a uniform graph. You can see it's not all exactly the same, but it's reasonably flat all the way across. It's pretty uniform. You can have a graph that's symmetrical, like so. Again, you can see that it's not exactly 100% absolutely symmetrical, but the general trend of what's happening on each side is the same. You can have a graph that is skewed to the right, so it's heavier in one direction than the other. The part that it's got a little bit of extra outside in is the tail. So this one is skewed to the left. This one is skewed to the right. There's most of the data falls on the left, and there's a few points off on the right that are possibly throwing things off. The tail is on the right. It's skewed towards the tail, not skewed towards where the majority of the data is, which is, if you're like me, that's your knee-jerk reaction. Is skewed means more of it's there, and skewed means more of it's being more of it is it's skewed towards the tail. I'm losing my train of thought as the thunder rolls through, I guess. Skewed to the left is exactly the opposite. We've got a tail on the left side. Most of the data is on the right. Okay, so let's identify some graph shapes. This one. Take a minute, tell me what shape you think it is, and proceed. Unpause when you're ready. Um, yeah, it's symmetric. If we were to imagine a curve just kind of touching the top, it would look fairly even. If we drew a line down the center, like they've done here, it would pretty much mirror each side. So it's symmetric. Okay, that is it. This was a short section. Um, I am going to take a break. We will cover section 3.1 in this group of units as well, but it is a bit longer, and frankly, my voice is giving out, and I want to do a few things while I still have daylight. So I'm going to take a break from this and post these ones and get back to you later.